In lesson 69, we're going to look at properties of trapezoids and kites. First, let's look at a trapezoid. Let's go a little bit deeper depth here with trapezoids. I want to label some things. First of all, if you remember, trapezoid has one pair of parallel sides, opposite sides. Those opposite sides that are parallel are referred to as the bases. The sides that are not parallel are referred to as the legs. Okay? So those are just parts of a trapezoid. But let's look at properties of trapezoids and kites. The first property is if a trapezoid is isosceles, meaning congruent legs. So if I have a trapezoid that looks like this, and the legs are congruent, this is known as an isosceles trapezoid. Okay? If a trapezoid is isosceles, then both pairs of base angles are congruent. Well, if you remember, here's a base, here's a base. So my pairs of base angles are congruent. There's property 1. Property 2 says if trapezoid is isosceles, then the diagonals are congruent. So if I draw diagonals, boom, these are congruent. And then the third one is actually for a kite. If you have a kite, then its diagonals are perpendicular. I'm kind of jumping around in this lesson, but to me, just going over the properties first made sense. They actually start by teaching but those are the properties, but they actually start by teaching a mid-segment of a trapezoid. And so a mid-segment of a trapezoid is the segment whose endpoints are on the midpoints of the legs of the trapezoid. So here, EF is our mid-segment. And since these are parallel to each other, and it's going to the midpoints on each side, therefore EF is also parallel to DC and AB. In example 1, it wants us to find the length of EF. Well, the mid-segment of a trapezoid formula is simply this. It's very easy. EF equals 1/2 times the sum of the bases. And our bases are AB and CD. So all we have to do is plug in our numbers here. 15 plus 25, and then times 1/2. So 15 plus 25 is 40. 1/2, therefore 20 feet is the measure of our mid-segment. And that's all you have to do there, pretty easy. Now let's look at a couple of examples that explore our properties that we just used. First one is example 2. It wants to know the measure of angle P, M, and O while giving us N is 107. Well, property number 1 said that if a triangle is an isosceles, trapezoid is an isosceles trapezoid, which this one is. I forgot to put my tick marks there. If it's isosceles, then our base angles are congruent. So this angle is congruent to this angle. 107 is congruent to M. So we call that one 107. So how can we solve for O and P? Well, in a polygon, its inside angles, or its interior angles, or quadrilateral, sorry. Interior angles add up to be 360. So what we can say is angle M plus N plus O plus P equals 360. Plus angle O plus angle M. P, sorry. So we add 107 and 107 together to get 214. Now since we know that O and P are the same variable, we could just say plus 2 angle O. Since they're the same measure, we can substitute this to be angle O. We subtract 214 and get 146. 146 equals 2 times angle O. Divide 146 by 2. Hopefully you can read my handwriting. 146 divided by 2 is 73. So each of these angles is 73 degrees. And that's how you use that first property. We're going to skip the one about diagonals in an isosceles trapezoid, and we're going to move to the kite in example 4. It says find the side lengths of kite W, X, Y, Z, and then round to the nearest tenth. Well, if it's a kite, we already know consecutive sides are congruent. So how do we find these side lengths though? We're given all these parts of their diagonals. Well, let's refer back to our properties of a kite. Well, properties of a kite says that diagonals are perpendicular. So since the diagonals are perpendicular, what can we do with that? Well, if I divided this into little triangles here, because we know all of these sides, well, let's look at this triangle first. What do we know about this triangle? Well, we know this is 5. We know this leg is 4. And we only need to find x. So therefore we can use Pythagorean theorem. 4 squared plus 5 squared equals x squared. Remember, hypotenuse squared is isolated. 16 plus 25 equals x squared. 16 plus 25 is 41. So square root of 41 is WZ and WX. WZ and WX is the square root of 41. Now we need to find ZY and XY. So let's look at this triangle here. Okay, this triangle looks like this. We are given 5, 8, and we need to find x, y. I'm going to call this a little x. Do Pythagorean theorem, 5 squared plus 8 squared equals x squared. 25 plus 64. 25 and 64 add up to be 89. So square root of 89, ZY and XY. So those are all your side lengths, but we were able to solve for those by using properties of a kite. It did want me to round to the nearest tenth, so you could do that, but you got the idea of how to use those properties. But that is all that we have in lesson 69.